Hello. Hey, JFix. Hello, hello. Welcome, welcome. Dig for some more PS5s. Power supplies to work on. Hello. Welcome, welcome. Come on in. Hello. Gear. I think it's pronounced Gear. Hello. Oh, there's Andy. Hi. Dave. Come on in, Dave's unbranded. Welcome. I need to... Hello, Lester. I need to work on some more power supplies. Is it? Oh. Oh, there's worms. Oh, it's not T on the end. Well, I'm sorry if I pronounced it wrong. This, you see this little diode there? I chased trying to figure out the proper part number for this thing. I couldn't find a data sheet on it. It's from a power supply, PS5 supply. And I looked and I looked. It's an ON semiconductor, VN16. And then I figured out finally that the actual part number is the B36B at the bottom. So I did figure it out, but yeah, Jay Fix, we had a good time helping Dave get that PS5 going. Kevin, hello, David. Falcon, everybody's coming in. Welcome, welcome. Let me switch back to the overhead. Okay, I've got a few more PS5 power supplies I need to fix. And I do have some PS5s to fix. I got 3 right now. Let's see. Still haven't put all the parts up from the... I think I have, I see 2 more in the box here. Looks like I have fixed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This one is an interesting one. I don't know if we're going to... I may fix this one eventually. It says water damage because I've opened it. Water damage doesn't really describe what's happening in there. It looks as though it was submerged in water, like from a flood, and it had power applied to it. And so there's a lot of missing copper traces, stuff that's just eaten away. It definitely had power on it when it was submerged, but you can tell like the whole thing was obviously submerged. I'm guessing it was maybe from some of the floods like last year out east in South Carolina, North Carolina, that area got flooded. And that's what it just looks like. It's bad. So anyway. I missed that part. Let's see what I have in the box over here. What is this? DR. I have mostly DRs. In all these I've gone through, there was only one ER, which would have been most likely come out with the 1115. So I'm going to start on this one. I need to make a schematic of this one and the ER. Yeah, I just finished up on one this morning. I did keep working on supplies after I got through streaming. So sorry, you may have missed some repairs. Some of them are interesting. Lots of exploded opto-isolators, burned resistors, shorted capacitors, the usual suspects. And no, I have not plugged this in yet. I'm assuming all these in this box that were given to me, they're all dead. Some more dead than others, but they're all pretty dead. Yeah, I missed most of Joey's stream. I had to go run to the grocery store. Come on, no roaches, no roaches, no roaches. All right, no roaches. Nope, no roaches. All right. Oh, you're right. Jay fixed my camera. Why does it do this? Why does it do this? This is OBS under Linux, and it just changes its mind sometimes. The cameras will shuffle around, and I can't explain it. All right, what about microscope? Is that in full? Yeah, it looks like it's full. Thank you, thank you. Huh. I mean, I didn't resize that. Not that I remember. Yeah, we all like to moan about OBS. It's free, though. We have picture. We have larger picture. Yes, we do. Thank you, though. I had not noticed that it was shoved in the corner like that. I'm sorry. Okay, nothing burnt. This is going to be a simple one. Very simple and straightforward. Continuity mode. How's our fuse today? Fuse is good. Still doing its thing. And our fusible resistor down in here, it is good as well. That's going to mean that our MOSFETs are good over here. Yeah, that's me. So, no short on the output. So, nothing shorted, which most likely just means we have a bad DAP053. If there's nothing shorted anywhere. Let's see. Diode mode. Okay, yep, right away. Pin 1 is shorted. And pin 2 is open. That's odd. And 3, I'm sorry, let me get my leads turned the right way. That could explain many things. Well, pin 1 is still shorted. Now we have a reading on 2. 3, 4 is ground, 5, pin 6, pin 7 is spacer, 8, 9, that looks a little bit odd, but whatever, 10, usually these are both reading like over 1 volt. But anyway, oh, we have another shorted pin. Was it 15? 15.05. And 16 is okay, so 15 and 1. It beeps on 1, but it doesn't beep on number 15 for some reason. Guess one is quite a bit lower. What does pin 1 connect to? One moment. What does pin 1 connect to? Hello. People still coming in. Oh wow, up to 43. I love to see it. Come on in, the door's open. We are going to hop right into repairing something. Pin 1. Pin 1 is the AC input sample. Let's see if I can fix that. Yeah, pin 1 is sampling your AC input through some high value resistors. So it's probably just a bad chip. Because like a short over here, you'll never know it. You've got over 20 mega resistance between you and a short back over here. This is a temperature. They get two uses out of this pin 1. It's sensing like the peaks of the AC voltage coming in, and it's also, if you pull it to ground through this resistor, it's a shutdown, over temperature shutdown. So they get two uses out of that pin. And 15 was the other shorted one. 15, I think, is what they call the half bridge sense. It's going between the junction of the two MOSFETs. Is that 15, or am I thinking of another one? I think it's one. It does go back to there. They're coupling off a little, sniffing a little bit of the pulses coming off there. I'm betting this chip's just bad. Because, like, look, you know, it has to be. 15 is shorted, and there's a zener there, but other than that, we're capacitively coupled back this way. So let's take off that chip and see if these wonderful shorts go away. How's that sound? And no, I'm not going to forget to switch to the microscope. Not this time. Not today. Hello, Picatronics Repair. All right. Let's see if we can get to this now. I'm trying to make sure I get this stuff in focus, and sometimes it's hard for me to tell how it's coming out on camera, if you know what I mean. I think I did get my microscope video worked out. I had to change some settings. The way it was, I did a stream some time ago, and it was also like cropped. The image was cropped for some reason, and of course what I was seeing was not what everybody else at home was seeing. I think we got that worked out though. All righty, a little 350C air. And of course, these chips are glued down as well as soldered. So we have to pop it up gently. And I will hang on to that chip for now. We have not proven that it is bad yet. Okay, let me see if we still have a short on this pin 1. No, like 36 k ohms. And what about 15 down here? Infinite. So, most likely, that was our only issue. Although it may not be. Although I don't see any signs of, obviously, of lightning damage or anything. No big arc marks anywhere, anything like that. All right. I'm going to put a TEA 2016 in here. And I'm going to turn it the right way this time. I have been known to turn it the wrong way. They get very hot when you do that. They don't like it. Kind of like putting a capacitor in backwards. They don't like it. Reminds me, I need to order some more of those big filter caps like I changed the other day in the stream. What are they? 150 microfarad at, 450 volts. I only have one of those left. These legs are always tarnished. And these are new chips from Mauser. So, but that's how they are. I'll have to solder every pin. I mean, it may be attached on the back side of the pin, but I want to see some solder coming up over the edges. Oh, we're up to 50. Oh yeah, it's pretty, yeah, it looks pretty, yeah, I can see the video here. I think but I had it the other day, it was shoved off the other side. Anyway, that was a few streams ago. And I can't remember, I changed the output format of this camera. Get up on those legs. Oops. Okay, let me leave that alone. Hopefully I did turn it the right way this time. Let's see if I can get, I'm going to go ahead and get rid of some of this flux, or all of this flux. I know I left a bunch up under the chip. So we're going to get rid of that. They're nice and clean. Let's see how it looks. Looks pretty clean. Looks almost factory. Okay, now let me go back and check the diode readings again. Since we have eliminated the chip as an issue, I don't think we'll have any low readings now. It's probably just going to work now. 1, 2, 3, 4 is ground, 5, 6, 7 is no connect, 8, 9, 10, 11, 12 is no connect, 13, 14, 15, and 16. That's a beautiful chip. Let me check one thing. With black probe on ground, pin 2 is the sense for the boost voltage. Should measure about 100K. 100K, okay. There's a little, is it Q32? There's a MOSFET over here that will break down and basically cause it to shut down when it shouldn't. Is it that one? No, it's not that one. Is it that one? I'm going to find it. Is it Q34? Oh, come on, get on there. No? It's one of these MOSFETs. Which one is it? Anyway, but it will it'll pull pin 2 low, and you'll get less than 100K ohm resistance. Or what you're reading is it's a divider change. It's like 7F meg, 7F meg. I don't know. There's 100K, but at the very end, going to ground, there's 100K, and you should measure that 100K on pin 2. But if that MOSFET is broken down, you'll get something less than that. I think she's going to work. Find out. I have got a mess of leads here. I have been in power supply mode for some time now. I'm just about caught up. I've had that box of supplies on my floor for a while. I was telling myself, I'll do a live stream sometime. We'll fix those, and it just never happened. I'm ashamed to say it never happened. So now we're doing it though. Let's see. See why it just moved that around. Why you do that? Why do you do that? All right, let me get this set up where we can see everything we need to see. Now I can leave this in the corner. But it just, OBS just like says, no, I want it over here today. I want to put it over here. It's a bit of a weird layout, but whatever. Let's see. I'm trying to get where you can see what I'm seeing, because we are going to monitor the PFC boost voltage to make sure it does not run away with itself. And we start blowing capacitors up. Okay. What else? I guess I could move some stuff around. This looks a little cluttered. Okay, the load set for 5 amps. Oop, turn it on. This, I was going to monitor the output voltage across the terminals. I'm assuming it's actually going to turn on. It may be a big assumption. Okay. Okay, so PFC voltage here, output voltage and current here, output voltage directly at the terminals here. Yeah. Okay. What could go wrong? Starting off with the voltage all the way down. And I will start, I need to get my arm out of the way, don't I? Start bringing up this. When we get to about 100 volts here, let me get rid of that reflection. About 100 volts, rectified. she should start trying to fire off. All right. It works. It works. Trying to get that where it's turned around. Yay! 12 volts, 5 amps. Yeah, we're gonna have to crank it up some. Oh, a lot of people streaming at one time? No, I'm sorry. We will see if it will handle 30 worms. We will. We shall indeed. It's not fixed until it does 30 amps. Actually, I take it back. We can do it, but this one won't do 30 amps. Not. I'll show you. I'm going to show you. With that TEA 2016 in there, and we get to about 28 amps, it's going to start getting unstable. Yep. So I'm going to crank it up to 10 for right now, because I'm still plugged into my isolation transformer. We're still fine. And you can look at there's the current draw. Let me get my thermal probe lead out of the way. You can see we're drawing like 1.2 amps. I'll put it back to voltage. About 1.2 amps. But we're solid there. That's about all I can go. I think this is a 2 amp fuse in here. It says isolated 2 amps. So I can go a little bit higher, but I don't want to. You have to disassemble this thing to get to this fuse. So I've blown it before. And somewhere in all these drawers, I've got some spare 2 amp slow glow fuses, but I couldn't lay my hands on them right now if I had to, but I know I bought some. And if I was smart, I may have left a spare one inside there wrapped up. That sounds like something I would do. Okay. So let me turn this back down to 5 amps. And we will go straight to the outlet back here. And she should come back up. Yep. Only drawing 5 amps. Okay. Now what I'm going to do is I'm going to start cranking it up. Keep an eye on this PFC boost voltage here. Looks nice and stable right now, right? Output voltage is stable. All right, we'll go up to 10 amps. No problem. 11, 12, 13, 14, 15, 16, 17, 18. Let me turn my fan on to blow across this thing, because it is going to be making a little bit of heat. So I do have a fan blowing across, a little cooling for it. We've dropped down to 11,998. No problem there. 19, 20. Still stable. 21, 22, 23, 24, 25, 26, 27, 28. She's hanging in there. 29. Oh. I heard it make an audible noise. 30 amps. It's working. It's working. You can hear the blower heat winding up on this load here. All right, that one did not get unstable. I've just usually about 28 amps. Some weirdness starts happening. But no PS5 area is ever going to pull that much current. Okay. We can set it on 10 amps, let it sit there and run. All right, it made a fool out of me. It did not get unstable. She's working. Oh, hey, Chatfix. Good to see you here. I know you were streaming. I wasn't trying to step on you there or anything. I had been waiting this morning to do some repairs. All right, I think this one's going to be good. It did 30 amps of current at 12 volts. Stayed stable. I mean, what more do you want it to do? All I had to do was change out that one chip. And that one chip cost me about $2. And I have a few hundred of them. So, totally worth it. Capacitors are not swollen. I'm going to put my finger on these. These are nice Rubicon capacitors. These are nice. Oh, these are 220s, by the way. I have those. I do have 220s. I have lots of those. But some of them, I'm not sure if it's the same model, the DRs. But some of these, maybe it's the FRs, I can't remember. Some of them have 150s and some of them have 220 microfarads. But I have 220s. I could use those if I get in a pinch and need something. All right. That one's done. I'm going to wind this back down to 5. I like to start at 5 amps. That's just me. All right. Let's unplug it. Discharge some caps, which I like to do before I start handling it. Just seems like a good thing to do. Let me switch back to. Seems like it's a good habit to get into anyway. Oops, I slipped. That was not an arc, I just slipped. All right. Unclip. So we definitely have a bad chip. It's going in the garbage now, so I can't get it mixed up with something later on. Well, that was easy. Yeah, that one fell right in the latches and everything. Let's see if we can get that big red X off of there. At least it looks red. It was blue. Screws. And let's stick a nice note to myself on here. This is a 400 DR, so ADP 400 DR repaired. This is so that when I'm digging through this box of them, because I need a certain model, I can easily spot it and not have to get the light just right to read the labeling over there, the embossed labeling. All right, now that goes in the box. Oh. With these. One more. Okay. How many? How many's in this box? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have another one. Step right up. We have another one. Oh, I like it. Andy's better at switches than I am with these things. Oh, the box with the broken ones? Actually, it only has... That's the last of the PS5 supplies. I've got some PS4 supplies in there. I've got this water damaged PS5 supply, but that's for when I feel like torturing myself. But there are several, you know, that's a 4 Pro supply. We got some 4 Slim. So I haven't worked on any of those in a while. Probably still could. I just have to find some of my information. But so there's like, yeah. And there is an Xbox supply in here, looks like. Is that for the, I don't know which one that's for. Is that for like a Series S or something? Anybody recognize that supply? Yep, it's an Xbox. Which model of Xbox? Because I don't know. I don't really. But it's for one of the. I'd have to look it up. I don't think it just says made in China. I'll put 12 volts, 20.42 amps. And I have worked on I fixed an Xbox One S supply a long time ago. I guess that's supposed to go right there. Just because I wanted to fix it. I mean, they're easy to come by, but I like to fix supplies and not throw them away. But that little post has been over. But I know they're all potted up inside usually. Like they like to put that celastic type white potting material all over it, which you can pick off. But my goodness, it takes a while. That's a Series X. Okay, I need to fix that one then. So I have a Series X, a broken Series X coming in from eBay. Haven't received it yet. I think it's just got what I think it is. I'm not sure if I'll do a video on it or not. I think it was a ripped HDMI. I think the owner, if you can believe what they say, took it to a shop to get the HDMI port replaced, and they didn't fix it and said something about that the port was stuck to the board. Yeah, that's kind of how they're made. They're stuck to the board. So, and in the pictures, from what I've seen, there's no port. The HDMI port is not sticking out the back. So I kind of figure it's going to be, I'm hoping it's completely functional other than it's a train wreck at the HDMI port. Because sometimes I like to do those. So, because I don't have a Series X, not a working one anyway. I think I've got one other one in a box somewhere. I don't know why I hang on to them. So I've got I kept a PS5 Slim that I repaired not too long ago. Although it's sitting in the floor, hasn't been turned back on. I don't know why I hang on to these things, because I never play them. But I might someday, just so I have the option to. But I have 3 broken PS5s in the floor behind me in the boxes. And I don't remember, I'm sure one or more of them is a no power, which could be a power supply, which could be a Southbridge. And I am out of Southbridges right now. Although I'm sure I've got a board, I could pull one off and reball, which I probably wouldn't like that because I'm probably going to manually reball it with solder balls. People ask why I do that, because when I do that, it works every damn time. It works. I tried, the last one I worked on, it needed a Southbridge. I tried using the stencil and paste, and it ends up, the balls end up merging. I could see them merged under the edge of the Southbridge. Because it's just, to me, it's that the paste, it's like it's softer. It compresses so easily. And so I take it off. I reballed it manually with solder balls, 0.45 millimeter solder balls, and it works every time. Anyway, so that's why I do it that way. These things love to hang right there at the connector, at the AC input connector. All right. I forgot to say no roaches. I did forget to say it. Oh, this is a DR, by the way. This is another DR. These lovely green DRs. I like this color. What's going on? I don't. Nothing burnt. No roaches. No scorch marks. It looks perfect. Of course, the last one did also. What are we saying? Oh yeah, Andy likes his paste. I get it. I've used paste on, like the stuff Andy works on, the switch lights. If you go to reball those tiny little DC-DC converters, the ones marked ALJ and AJZ or whatever, those little tiny thing, even like the fuel gauge. And if I do it with paste and I put it down, it wants. You have to. I know I've got to be better with my air pressure on using the airspeed. It will squish down the chip and merge the balls together, because that paste to me is just so soft. That's just my experience. But I've gotten better. I have been able to do it here recently, but I have to back down. I'm not used to backing off the air pressure. My air runs usually at full volume all the time. Usually, if I'm reballing a chip and I'm trying to flow the balls into place, yeah, then I've got to back it down. Unless I want to have a pile of solder balls stuck to one side and melted together, I'll back it way down. But otherwise, for most things, maybe I'll adjust the temperature, and as far as the airflow, I just raise or lower the tip of the thing. But that's just me. Okay. Okay. Yeah, this is my favorite meter to work. By the way, if you may have noticed, this is my favorite meter, but it was so much of a favorite, I bought another one. Used one. I was going to show you. And when I bought this one, the display was dead in it. So I bought one from this guy on eBay, a replacement display, aftermarket display. And it just looks so beautiful and easy to read. You've got some flicker, I know, in the camera. Of course, that's not visible to me. That's just the difference between the update rate of this and the refresh rate of your camera. But I didn't realize how much better this looks than the original one. And so that's why I thought they always looked this way. No, this is how the factory one looks. I'm sorry, let me get everything in the shot there. This is how the factory one looks. The pixels are further apart. It's not anywhere near as bright. So I've gone ahead and ordered another replacement one for this one. And the guys on eBay, he sells them in the orange or in white. So send me a white one so I can see what it looks like. I've seen pictures, but that way, anyway, I'm just a guy with his toys. And I do have a bit of a multimeter affliction. Anyway, back to, meanwhile, back at the ranch. Fuse is good. How about the fusible resistor? Yeah, fusible resistor is good. Well, that means these MOSFETs are going to be good. Because if they would have shorted, that resistor would not last very long. All right. It's time to to see how bad is this chip. Am I in diode mode? Why is pin 1 reading open? Okay, that's odd. 2 is shorted, 1 is open. Okay, not starting off good. 2, 3, 4 is ground, 5, 6, 7, no connection, 8, 9 is good, 10 is good, 11 is good, 12 is no connection, 13, 14, 15 is shorted, 15 shorted, and 16 looks good. These pins that are no connection, I think it's, what is it, 7 and 12, those are the data and clock lines for the programmable version of these chips. They serve no function on these, but if you buy, you can buy chips from NXP that have those, you know, they call it a development kit. I was looking at the software and stuff for that, but I think they'll give you the software, but you got to buy the $200 and something development kit to get the chips, and so you could make your own programmable chips. But you know, not really hardly worth the trouble, I don't think. But I was just looking into what those, you know, there's a diagram online that's one of those is serial data, one of them serial clock, but on this version of the chip, it's just a spacer, a high voltage spacer is what they call it. Anyway, so that's 15 is shorted, but our MOSFETs where is our power factor correction MOSFET? There's the diode, there's the MOSFET, and that's ground. So our PFC MOSFET does not seem to be open or shorted. So nothing seems to be shorted except for the DAP053. So let's take it off. See if all of our shorts magically go away. I'm just checking the chat. Worms, you like multimeters? I like multimeters. I have many multimeters. Y'all have never seen this one. I bought this just because it's an old, and it was just so cute, the size of it and the display. Had a bad battery, but that wasn't the main problem. It wouldn't read anything. I didn't do a video on it, but it was neat. This thing, there was a cold solder joint on the resistor that carried basically the sample voltage into the chip. Right there at it, it was from the factory, was not soldered. And so it took me forever to find that. But anyway, I do have a bit of a soft spot for multimeters. Anyway, but it's got internal rechargeable batteries. It's just cute. Will I do on-screen meter? I can do on-screen meter. I can do that now. I do it with a laptop, and that laptop is sitting in the floor. I mean, I can hook it up. I've done it before. It's just a bit of I can use my, I've got a Siglent SDM3055 on the workbench here, and I use it came with a piece of software for controlling it, and I use that, hook it to my laptop, and then I take the video out, and I can put that on the screen. I can do that. It's just a matter of how lazy I'm feeling at the time. And I didn't feel like doing it today. So I'm not a professional YouTube person. Darn, Try and get a hair off of there. Not a professional. All right, let's get this chip off. Yeah, I've done some videos with the on-screen meter and stuff. To do it with this Agilent, I'd have to buy there are some infrared. There's an infrared data port on the back of those meters, but I don't have the cable for it. I'm sure I could find it. But then you have to find the software to talk to it. Anyway. Don't know why these chips go bad so much. I'm guessing it may be, power surges. Because some of the pins on this thing, they're not directly tied to the AC line, but they're not far from it. Some of the sensing stuff. So, a spike has a good path to get to this thing. There we are. That's just the best way I found of different moving that chip, is just doing that. Just be careful and don't lift the traces. Just have to watch. Because it's glued down, I mean, you could cut the leads, any number of ways you could do it. I was going to clean up those pads a little. Maybe add a little leaded solder to it. All right. Is our shorts gone? I bet they are. I'm going to go in continuity mode. Just want to check. I believe it was 15. Yep, it's OL now. 1 is OL. 2. Okay. Is that all it was? Yet another. Let's put another chip on here. All the shorts went away when we pulled that chip off. That's what we like to call a clue. That our chip was bad. And my tweezers are sticky from flux. I think this is the last PS5 supply. We're going to have to move on to a PS5. I have to sit down a little bit more. Although it has glue under it, so it's not going to want to sit down too much. Those little pads of glue. Can't let it go down all the way. But if I try to scrape those off, I end up doing more harm than good. I end up digging into the board. Come on, get up on top of those legs. Well, I was watching Andy's stream this morning when several of you were wondering if I was lurking. I was lurking. But I just chose to stay silent. As is the job of a lurker. It's in the job description. He does start his streams though way before before I did that, but I usually catch it somewhere in the middle or, somewhere in there. I don't miss everything. What I do, there you go, here's my bottle of alcohol. All right, does it look clean enough now? Not bad, not bad. I see a little flux there. We want it to look clean. All right. So, let me go through it one more time. Just to make sure all of our diode readings are good, because I'd rather not waste a fuse or a MOSFET. One, sorry, I keep slipping. 2, 3, 4 is ground, 5, 6, 7, no connection, 8, 9, 10, 11, 12, no connection, 13, 14, 15, 16. Beautiful. So, it looks pretty, but will it work? Will it work? Let me turn it the other way. There's that. Okay. This is not plugged into my transformer right now. Load is on. Let me set up a meter. Let's get set up. No kick streaming? No kick streaming. I do good to stream on YouTube. No, I guess I'm just not multi-platform. Not yet, anyway. All right, what am I missing? We're monitoring our PFC voltage, or boost voltage, I should say. Load is on, set for 5 amps. Let me wind that down. Try to keep my arm out of the way of that shot. That's hard to do. Okay. It's a heck of a glare. I'm gonna bring it up. I don't hear anything humming or buzzing yet. Look at there, 12.1. Around about 393, 394 on our PFC voltage. That's on the money. .1 at 5 amps of load. Oh, I understand, Rusty Russ. Yeah, I get it. I get it. Honestly, I'd never heard of Kick until Joey started using it. I'd never heard of it. So, yes. Shall we just assume that it'll do 30 amps, or should we actually try it? Well, we have to try it, I guess. All right, like I said, I'll run it on up to 10 for right now. Take a look at the current draw. Yeah, we're drawing about a 1 1/4 amps or something like that. She's stable. Let's go straight to the outlet. She came right back up. And what happens? 10 amps. 11, 12, 13, 14, 15. Voltage is starting to drop a little. That's all right. 20 amps. We're still stable. 25 amps. 6, 7, 8, 9, 30. 30 amps. I forgot to turn my fan on. 30 amperes. 12.006 voltage. What's wrong with that? Look at the drop across my leads, which are now carrying 30 amps of current. But yeah, I need to make some better leads. I mean, this is working, but bring her back down. I believe that'll work all day. It is pretty impressive how much they supply. Up to 73 viewers? Wow. It was just the IC. I think I am out of broken PS5 power supplies. Unless I have some somewhere in the closet, we may just move on to a PS5. Well, I will tell you what, let me put this back together, and I'll show you the inside of this flood damaged PS5 power supply. Let's unplug this thing before I get all happy and start disconnecting stuff. Let me put that meter back on so I can watch that voltage bleed off. When I discharge the capacitor here. All right. We are good. We are good. Find the covers. Get back in those little snaps. Find my screwdriver. Little plastic snaps that hold this board down. Like to be a little difficult sometimes. There's one. Here's the other one. There we go. Snap securely into place. Get rid of our big red or blue X. Blue. Now, where's my notepad? And this was a DR, yes. ADP 400 DR. Professional labeling. That's just for my use anyway. Come on, fan, work with me here. Oh, I could put the screws back in it, don't I? Just noticed that. Lacking in the screws department. Come on, fall off in there. All right. Yeah, that was a bad chip. Throw that away. So, one more for the pile. Mostly DRs, occasional FR. I can't really read that, that's overexposed. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Box is getting a little heavy now. Oh, we're going to look at this thing right quick like. Except I put some tape over one of the screws. I did not snap it back together. Okay. I'm not sure how much you can see from that camera. So we're gonna have to go into the microscope. When I look at the liquid signs of liquid in there. It was submerged, I'm rather sure. Then with the screws. What did I do? Oh, there's the other screw. Some burnage there. So, yeah. Put that back in there. Let's look at it under the microscope. I'm not going to fix this today. I just don't have that kind of time. But I will show you. Microscope. Nice hole burnt through the board there. Look at those traces right there. Completely gone. Because this is at, like line voltage. A lot, get that in focus. a lot of damaged end caps. Look at these resistors. Look at all of them. Look at how you know, wavy this stuff is. Like, a lot of these resistors are just not going to be any good. And you wouldn't want to trust them. You know, like that one. I doubt that's a 1,000 ohm resistor anymore. But and it's this way all over. The whole thing was submerged in water, and it had to have had power on it for who knows how long. Yeah. But I'll probably give it a try, see if I can make it work again. Let me show you where that burnt spot is right there. If I flip this over and look down in there, can you see down in there? That's like the lines. Look at the line. Look under the bridge rectifier right there. If you can see that, one leg of the bridge rectifier is gone. It's not there anymore. Yeah. These capacitors don't look too healthy. So yeah, that looks like fun, doesn't it? Yeah, Carther, it is fixable. Anything's fixable. Anything's fixable if you got enough time and money. Anything's fixable. But anyway, I just wanted to show you that. Yep. But I mean, that's the only way I can figure it. It had to have been submerged for a while to get this bad. It had to have had power on it. I mean, that wouldn't happen if there was no electricity on it. You could put one of these things in water and really wouldn't hurt it unless you applied power to it. And then you get bad things happening, obviously. So I'm going to slip this back together. It's going to go in a rainy day pile maybe or something. But that would take a while to replace every resistor or every surface mount resistor, because I mean the few that are working are going to be the wrong value. The value won't be right on them. And to know, you'd have to lift every resistor to check them, but you're better off just replacing them all. Okay. I need to make some room on the bench because PS5s are large. I need to restock my cotton swabs. Well, they didn't go as to plan, but whatever. Get in there. Need to do something. Some MOSFET I ended up changing out. It looked like somebody had worked on the power supply and they ended up flexing the leg so much it just snapped off. But it's still a good MOSFET. The leg's just broken off of it. All right. Let me see what I have in the way of PS5s. Let me see, I gotta look at my listings where I bought them. See if we can find a good no power PS5. That's my favorite. Oh, my liquid metal Q-tip fell down. And now I have liquid metal in the corner of my mat. not good. It gets on everything. Okay, let me give this a quick clean. Haven't seen anything else come in today, but I guess it's still relatively early. What time is it? It's 11 o'clock here. 11 a.m. So a little early for deliveries, unless it was like FedEx or something. All right, let me take a look. Let's see what I have to work on. Got some switch lights coming in, not here yet. No power. Oh, that one's not here yet. If I track it, oh yeah, it's funny. This a PS5 I ordered from. It came from Texas. The United States Postal Service thought it would be fit to ship it to Puerto Rico. So now it's trying to make its way back from Puerto Rico. Yeah. So that one's not here. Here's a no power. Yes, I like this one. The order details. All right, tracking ends in 9535. All right, I am on the hunt. That's not it. That's not it. That's it. That is it. It's in a box that had diapers and wrapped with duct tape. So that's how you know it's good. Let me get this open. What does this say? Let me look at the description. Where is the... Okay, original listing. This could be a total disaster. I don't know. See original listing. It just says no power. Okay. That's all it says, no power. It's a fat. I always wonder about, sometimes they say no power, and what they mean is it doesn't give them a picture. Anyway, some people just have different ideas about no power. To me, a no power is it doesn't do anything. It doesn't make a noise. There's no lights. There is nothing. That would be a no power. All right, there she is. I need to widen this camera out a little, don't I? How do I do that? Can I go this way? That's wide as she goes, isn't it? Oh, this cover's loose. Okay, that cover just kind of popped off there. She is not factory fresh. She is not sealed. Let me get where I can see. Well, hello. Does it say free roaches? I need to check the shipping. Or I don't see any roach stuff. I think it has a lot of dirt in it. I see a lot of dirt in the fan. Fan connector's not ripped. That's always a plus. I'm looking for legs and antennae stuck to this little piece of sticky tape. No legs or antennae. All right, let's give it some power. They said it was no power, and the people on the internet do not lie. Let me switch so you can see. Oh, that didn't work. That might work. Just long enough to, I want to see if this power supply starts. I want to know if that power supply is totally dead or if it at least starts. Okay. So yeah, when I give it voltage here, I'll turn it on. Let me tilt that up just a little maybe. This should come up to about 120 and you should see it dip down real quick, like if that power supply starts. It's just some surge. It loads this down a little bit. So what happens? Oh, it did start. It did start. So it's not a dead supply. Well, that's great. Now, does it beep? Let me get this in the shot a little bit better. And I'm knocking stuff off. Power supply is not dead, though. I saw that. It beeps. The light flashed, it went right back off. No power. Man, the beeper sounds really weak. But it looks like a short. It went on and right back off. This could be a disaster. You see that? Can you see the light? Let me get the light in the picture. Fan bumps around, blue light for just a fraction of a second, and then right back off. That looks like a short on the 12-volt line or something like. But it's no power. Quote, no power. So, all right. This should be fun. Probably not. I don't like how we're starting off. That's just not a no power. So I don't know if these people sometimes they just don't know quite what to call it or if they're intentionally being deceptive. I really don't know. Oh, that cable is damaged. Frayed. The power cable for the Blu-ray drive is. I don't know if they tried to pull it out with pliers or something. That's not really in focus, I realize. But it's damaged a little. It's not totally in two, but see if I can get this in focus a little bit better. One moment. Somebody in my driveway? Nope. Nope. Somebody in the neighbor's driveway. Not mine. So, may have to do something about that. It's just slightly damaged. So, we know somebody's been way into it. They didn't say it was untested, which is another. I always love when it says doesn't work untested. How do you know it doesn't work? It doesn't work, but we did not test it. We didn't. Oh, screw's missing. Well, so far, the screws that are here are in the right spot, so there's that. I hope this is not a burned circuit board or something like that. that out of the way. Screws are there. Did they? No, they didn't pinch the ribbon cable. So this is a 1015 or 1115? 1115. I should have recognized 1115. There's no antenna up here. I should have known that. There's no antenna at the back. Just has the single connection points. That should have been a dead giveaway. So this has been off. So they've been deep into it. No solder on the UART connection points. So doesn't look like they've done any code reading to it. Get that out of the way. And now we take out the unlimited number of screws. Yep, kind of looked like a short, you know, when you power it up short. That looked kind of like Southbridge, and all the other stuff was working just fine. There's such a quick cutoff, though. This kind of reminds me of when the APU and RAM voltages come up, and it figures out there's a problem. So I'm going to guess the initialization, the 300 milliamp initialization is probably just fine. It is strange though the way it tried to turn on every time I hit the button. Like it wasn't like usually you try to turn it on and it doesn't. It shuts down. You hit the button again, and it actually shuts off. It wasn't doing that. It was like trying to turn on every time. Not sure if that's a clue or not. All right, yeah, this has been up before. That came up way too easy. Not seeing any burn marks. Ethernet port's kind of messed up a little. A little bit of flux around the HDMI port. Is this an HDMI port swap that went horribly wrong? I mean, there's been definitely some signs of heat up in there. You can see the discoloration. I think that's the only flux I see right now. Get my needle nose. All right. Time to come out. And dry spot on the APU. I was looking to see if the HDMI encoder had been swapped. Can't tell 100%. Yeah, nice dry spot on the APU. So maybe they just, okay, let's look, let me get this out of the way. I want to look in that HDMI, maybe it just had an HDMI port replacement at some point in its life. Maybe that's all that looks like. Let's look under the microscope. Maybe it's just at some point in its history. There's definitely some signs of flux there. Yep, I'd say that's been changed. But, yeah, those anchor points look like crap, of course. But, I mean, I don't think that's why she's not turning on. I don't think. All right, what about this HDMI encoder? No, I'm going to say that's factory. That looks factory. So she's had a port replacement at some point in its past. But I'm not seeing any other signs of work anywhere. How about this? Is this thing cracked? I'm going to say no. I'm going to say no on APU crack, but let's do some measurements before we go too far and waste a lot of time on a dead processor. Resistance. I want to check. There's some small vias right here that carry some other, what is it? What's the voltage? 0.75 and like a 1 point, I can't, 1.5? I can't remember exactly. It should be like 200 ohms, 250, and this one should be in the K ohms. All right, that looks good. That looks good. Now how about over on these, the 6-phase and 2-phase? I think this one is this the one that should be about 0.2 of an ohm or something? Yep, 0.28. This should be more like 5 ohms or something, yeah, up in that area, 6.4. That looks fine. How about RAM? The 1.35 for the RAM. 23 ohms, a little on the low side, but it's probably Samsung RAM, and it's going to be low. No, it's SK Hynix RAM. That seems kind of low for some SK Hynix RAM, but I need to check some notes. It is SK Hynix. Not the brand I love to see, although it's better than Micron. 23 ohms, just make a note of that. Not as short though. Or how about our fuses? I'm just going to hit a few fuses around the board here. Good. Down in here. Good. That's the 5-volt fuse. I think that should be, is that F7001? Yeah, all good. Those are the fuses for the Blu-ray. Not worried about those right now. Fuse for the SSD. I think that's going to be good. Yep. So about these rails for the, I think this is for the CPU part of this chip, and the rest of this stuff's for like the graphics part of it. 26 ohms, that's fine. 3 ohms, I think that's fine. I like to check those. Let's take a quick look around the HDMI encoder on this capacitor. Couple hundred ohms? No, it's in the K ohms. Yeah, no shorts there. There's a 1.8 and a 0.9 volt rail into this encoder IC. And I don't really see a problem there. Let's take a look at its initialization current. I think it's going to be good because it is beeping. Time for UART? Yeah, UART is coming. UART is coming. Let's take a look. That's not the right one. See if I can get that power supply down there in the shot. Any chance of it focusing with all these other cords hanging in the way? All right, I'm going to give this board 12 volts. I think she's going to do just fine. Okay, and on. Yeah, 300 milliamps and come back down. Doesn't hang. That's healthy. So I was pretty sure that was going to be fine. So yeah, let's just see if we can read these codes then. Which I need to get my old decrepit laptop out. Just a moment. I'm using an old Windows 8 laptop that I had lying around, wasn't doing anything. And that's what I use for my Windows stuff because my main computer over here is a Linux computer. But at least I can get the video out of this thing into my stream. So there's that. Worms, you're cooking? I have put a roast in the crock pot for later on. It's going to cook about 8 hours. Potatoes, carrots, onions, mushrooms, seasoning. It's going to cook all day and be delicious later on this evening. That's my kind of cooking. I like to be able to put it together and walk off, and I don't want to have to stand there over it and do stuff. Here's my leads. Get into my laptop. This thing's probably going to have a lot of errors related to, sudden loss of power. Because we know it's had that. Because it cuts itself off. One moment. Yep, never been, no one's ever read the codes on it. Honestly, I think they took it apart, I guess looking for something simple, and didn't find it. Just going to tin those a little. So much fuzz on there. All right. Let me get set up. So I can share this. Should be working. All right. I need some power on this board, probably. Or it's not going to work. We'll give it 12 volts. She initialized like she should. Okay, do I have this? I'm looking for this. This is probably going to be messed up. Well, that doesn't look good at all. Why do you look like that? One moment. All right, now I'm going to yeah, it doesn't really, in this setting, you don't really have a preview option for this stuff, do you? Oh wow, the stream is like way behind on my. All right, I updated. Okay, my little view window for it was like 2 minutes ago. Hey, at least you've got something you can see now. All right. Read those error codes. And they scrolled off the top of the screen. Unexpected power cut, AC detect. Because these are going to, I may have to clear these and, you know, I just kind of wanted to go through them and see. Ooh, damaged RAM or APU post-boot. That's not good. Main SoC access error. Again, not good. A whole lot of errors. Main SoC access error. Unexpected power cut. Okay, we have a lot of errors. And this program does save them off in a text file, so we're not going to lose them. So let's clear those. All right, and now, well, I need to try to turn it on. Let me find a power button. I used to have one. Or I'll just use my tweezers, I suppose. Where? Oh, it's right there. It's on the other side. It's kind of hard to get to when you've got these wires connected to it. I'm going to knock my power leads loose. It's coming. Okay. She tried to turn on, but then again, my power supply went into current limiting, so that's not really a good valid test. We can look at the errors, but like I said, I heard my power supply click over there. It went into current limiting. It couldn't. It tried to draw a lot of current. Read. No errors. Really? No errors. No errors? Not a single one? Well, that's not very helpful, is it? No errors. It did try to boot up. Yep, I hit the power button. Yeah, this is PS5 Wii Tools. So I may have to slip this back into the chassis. I mean, it's at least, well, I could just stick a 12-volt supply on here. Where could I find a PS5 power supply that I could stick on here and try to turn this on? Where could I find one? Let's see. There we go. Oh. But at least this way, when I try to turn it on, it'll shut down for other reasons, and not because the power supply went into current limiting. What did I do? This is going to get to be a mess, though, because I still need to hit the power button on it. Ah. I'll just slip it back into the stupid chassis. Wonder if we have a bad power supply. Can't be that lucky. A supply that dies when the load hits it. I mean, I'm sure it could happen. Oops. I'm sure it could happen. This way I'll have some LEDs to watch. I'm not too worried about putting the APU clamp on it. It's not going to stay on long enough for that. Famous last words. It shouldn't stay on. It has yet to stay on that long. Overheating is the least of our problems. Okay. I don't know why I bothered hooking that up. I'm thinking about sticking a meter right across this 12 volts as I try to turn this on. Supply started, 12.1. And power. Ooh. That dropped to like 10 volts, was it? Ooh. So is it just a bad supply? Or is there a short? That voltage did drop down though. It did not stay 12 volts. it dropped down. So we need to swap out the supply. I'm afraid it's not that easy. But you know, I haven't found a dead short. I mean, to shut down a supply that can supply 31 amps, you've got to have a pretty dead short, if you know what I mean. There's no short on the 12 volt line. The 12 volts would be, as soon as I plug it in, there's 12 volts there. So it would have to be something, something that's turned on beyond the initialization. It's not straight on the 12 volt line. All right, I'm going to swap out the supply. I'm going to hunt and hunt until I can find a known good PS5 supply somewhere within about 3 feet of me. This could take a while. And I'm going to unhook those wires before I snap that off. Okay. Bear with me here. I'll take this other side plate off. Put it somewhere where I won't be able to find it later. Oh. One of these screws is already missing. Why do I think somebody's already done this? Yeah, only one screw in there. Somebody has already done this, I believe. But it's just a no power one. I mean, we don't know why. We're innocent. It is of course it's an ER. It doesn't matter. I've got DRs. I've got one ER in the box, but it's the same supply. I'm going to put a DR in here. And I think she's going to do the exact same thing. Because somebody has already done this. And they were too lazy to put all the screws back in it. All right. We have a known good supply that we have seen supply 30 amps. Supply started. We'll do the same thing. We'll meter across this supply. And when I go to turn it on, let's see, can we see the lights? No, the lights aren't in the picture here. Let me so you can see the ribbon lights. Well, not really ribbon lights, they're just LEDs. Okay, same thing. No, we stay on. Oh, we're going to overheat. Straight to a white light, I'm pushing down. There's a dry spot on that APU. And it came on. What gives? I mean, clearly they tried to swap the supply out. I was going to do the storage check. And it may overheat. I'm pushing. So that looks... So we've got a weak supply that's shutting down. All right, we're through. I'm going to try to shut her down so she doesn't overheat. Come on, shut down. My fingers are starting to burn a little. So, she turns on. I can't confirm if it has a picture now. That HDMI port didn't look too sporty there, but... So, yeah. What do we think? Faulty power supply, but why didn't they just swap out the supply? time is it? I'm sorry, let me catch up with Chad a little. Fixed in? Well, we need to figure out why the supply is not working. Because, I mean, I don't have many power supplies laying around. Tell you what, let me straighten up that liquid metal. And we'll hook it up and make sure it's getting a picture out, because I may want to change that HDMI port. It just didn't look that great. But we need to get the, of course, need to get the liquid metal straightened out, get the APU clamp back on there. And let's just make sure it does come up. And I just don't understand. I mean, one of the screws, I don't think I'm out of those screws. The ones for the back, but the pointy ones. Why wouldn't they just, why didn't they just swap out the power supply? I don't get it. Maybe it's banned or something, but people have been known to do that. You know, take a banned motherboard and a bad power supply, throw it together, and you know, call it a no power, untested. So it was the power supply giving in under load. Did not expect that. We'll make sure it has a picture, and we will we'll take that other supply. Where did I put that supply? Oh, it's in the floor here. We'll put it on the load, and we'll just see at what point it you know, gives up. Kind of curious to see at what point it gives up and what has failed in it. You know, could just be the controller. I mean, that controller handles about everything. That DAP 053. But on a positive side, we don't have a dead APU. So we got that going for us. And this APU should be a lot happier. Should be running a lot cooler with this liquid metal sorted out. Where did I put the clamp screws? Where did I drop the clamp screws? Well, it gave a white light, so it should be giving us a picture. Okay. Let me get it set up over here in my little testing spot. Got to clear a path to get to my testing spot. The number of boxes in my floor right now is a bit disgusting. Maybe I should hook a fan up. Although it is a little fuzzy. Okay. Let me spin this camera around, because we are professionals here. Nothing but the best. All right. Give us a picture. Oh, the fan is hitting my UART leads there. Come on. White light, no picture. Oh, and so let me is that intermittent? Oh, it is intermittent. So yeah, we gotta do something about this port. All right, give me a picture long enough to make sure it will, controller will connect. Yeah. Yeah. I wonder what firmware would we have? Just curious. 10.01. 10.01. But she's working fine. So we just need to figure out what's wrong with this power supply and fix that HDMI port, because that is very intermittent. All right, so that's that issue. I'm hosting lunch? That sounds about right. So here's that power supply. Let me go back. Oh. Let's go back and look over here. Oh, that one's messed up. Okay. Y'all still here? Everyone still here? Which cap do you check for a socket short again? Let me grab a board there. Let's look under the microscope a second. All right, looking at the back of the board, trying to get it in focus. Here's the area. I'm going a block. I think it's going to be that one right there, that inductor. It's not a cap, it's an inductor. But it's also the same point. If you go to the other side of the board with where the DA9065 is, or RT5126, whatever you happen to have, right there. If you check on that cap right there and you get like 1 or 2 ohms, yeah, your Southbridge has purchased the ranch, bought the farm. So, yeah. Well, hello, 10601. Okay. I hope I answered your question there, Chat Fix. I was a little late, but I guess I didn't see the question. I was trying to stay busy. All right, let me put that board away. So, here's our offending power supply. I gotta remember to get my UART leads back off that board over there. I will need those again sometime. No, not that one. Let's get where we can see this stuff up here. Although it's not really in focus too well. That's not too bad. I'm going to, let's get some power into it. Let's get DC load. Let's just see at what point it throws up. I think I got that polarity right. If not, my load will let me know in a hurry. It does not like it when you reverse the polarity on it. It does not like it at all. All right, I'm going to bring it up kind of slow. I'm going to move my arm out of the way. I'm sorry. Nasty habit. What do we... Oh, it doesn't even like 5 amps. Set. It doesn't even like 5 amps of current. All right, I've given, we're at 1 amp on. Okay. She'll do 1 amp. 2 amps. Oh, that's it. Nope, that's too much. 1 amp, and that's it. 2 amps, we fold like a house of cards. So, turn that off. Yeah, so, yeah. We will not, she cannot supply 2 amps. So, sure, you know, the amount of current, you know, it's only like 300 milliamps for the initialization part. That's all you need. But beyond that, where is my screwdriver? Oh, here it is. The ridiculously long-handled red screwdriver. Of course, this thing has had power on it recently, so we're going to have to be kind of careful here. And not forget to discharge. Oh, I put up all my pry tools because I thought we were through with power supplies. And I was wrong. Let's get this antenna off of here. Yeah, this is the 400 ER. Have not worked on this model as much as some of the others, but it's not very different from a DR. The FRs are a little different. The FRs you get in, you know, those have the DNP 014 on the cold side, handling all the regulation and stuff. Whereas this model uses like some op amps. They do it a little differently. It works, it's just done differently. Oh. Is that just, that would be like smoke residue. Not sure. Well, our capacitors are not swollen. Our main bulk filter capacitors are not swollen. There's really just some dust in here. I have not discharged this, so I'm not going to be handling it until I do. I don't know if it's water damage. I mean, there was like signs of like cigarette smoke. Why am I discharging the 12 volts? Yeah, we still had 30 something. No, that was over 300 volts there, wasn't it? Ouch, that would have hurt. That would have hurt a lot. Okay. Now, the most likely culprit here is going to be that DAP 053. Not a guarantee. There is some discoloration on here, but I think it's like nicotine. There's some brownness on some of these, well, already beige colored ceramic capacitors. I wonder, tell you what, let's check, let's get hooked up. Let's see what our PFC boost voltage is running. I'm kind of curious, because I've seen these things run when the PFC wasn't working right. They would try to run. And you'd have like 350 volts on the on those bulk filter caps. And it would try to run, even though it wasn't running correctly. It would try. If I get my little grabbers down in there. Okay. I guess I could hook the load up. I don't think we're really going to be able to load test it in any way. All right. Get that antenna lead out of my way. All right, let's see. I'm going to give it some AC. Whoa, 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 whoa. That went over 400 volts. I didn't like the sound of that at all. It did try to run, but that PFC voltage is still setting at 400 volts and bleeding off slowly. This doesn't seem. It made a strange sound too, an audible sound like from the transformers. Which, you know, a little bit of a, you know, vibrating sound momentarily as it starts is fine. That's normal. But this was different. That is odd, the way it's still bleeding off 395. Let me discharge this thing. I'm going to have to plug it right back in. Let me see. No, we still got 70 volts there. It just shot up there really fast. What's my load set on? Bring it. It was set for 2 amps. So hang on. Let me set the load for 1 amp or something, and turn it on. I'm going to wind this voltage all the way down and bring it up slowly, I suppose. But I'm concerned about that. Why did that go to 410 volts? Okay. It overshot, but then it settled back down to 395. That looks fine. It overshot it, I think, when it was shutting down from the. I had a 2 amp load set on the meter on the load over there, and it was going, I think, up, down, up, down, up, down, and overshot its voltage. That looks normal. How much current are we drawing? Oh, next to nothing on current because we're not taking any current off of it. We're drawing 1 amp of current on the load. I want to say that does settle down to a, that's fine, 396, that's fine. So there should be nothing wrong with the resistive, feedback divider. That should all be good. If that's regulating, that should be good. I'm looking at these filter caps. They don't look like they're bulged at all. None of the output caps are bulged. I'm thinking this controller is just garbage. That's what I'm thinking. They die in weird and wonderful ways. What's the voltage with 22 amp load? it's gonna vary all over the place. Look at it. There's 2 amps, and the output voltage is going up, down, up, down, up, down. That's a 2 amp load. That's what it's doing with the 2 amp load. It's saying, please make it stop. Okay. $341? When I shut it off, it likes to set it. That's weird. That's a little weird to me how it. Normal, when I turn one of these things off like that, you read like 270 volts there. That's what's kind of normal. Let's discharge it. All right. I think we are safe. And I think I am going to change that controller. As a first step. I mean, they just die and do weird things. We can put an actual DAP 053 in there as well. I do have a couple, 2 or 3 left here. Let's get it off of there. I mean, this just, because this chip is responsible for both the PFC voltage and the 12 volt voltage as far as the choppers, the DC-DC conversion stuff. Whereas in a lot of the old PS4 power supplies, you had separate chips. You had a little chip for the to drive the PFC, and a separate chip for the DC-DC converter. But now, I guess technology has gotten to the point where these common ones are, common as in they do it all in one chip. A common chip for the power factor correction and the DC-DC conversion. They do it all in one. And you can buy that TEA 2016 for $2 from Mauser, in quantities. Or you can buy the DAP 053 for about $8 to $10. Yeah, just when we thought we were through with power supplies, after doing 15 in a row, but I'm happy. The problem could have been a lot worse with that PS5. Could have had a dead APU. Could have had some shorted RAM. Very good clean. Getting rid of those nicotine stains as well. See that? You see the color on that tissue. There was some nicotine stains. I was wondering if that's what was causing our PFC voltage to wander around, because that PFC voltage divider for its feedback is rather high impedance. So it's usually like two 7.5 megohm resistors and then another 100K, or anyway. So it's a high ohmic divider, as they call it in the data sheet, and it does not like contaminations on the board. Let me see how that looks. Oh, that's beautiful. Beautiful, beautiful, beautiful. Take my word for it. All right. Is that all it needs? Is it that simple? I don't know. Find out next week. This could be a cliffhanger episode. All right. Let me get set up to show. Yeah. All right, so we're going to check that voltage again. I'm going to, I should have made my lead a little bit longer for my dummy load. Just a little bit short, any way you slice it. Okay. DC load is connected properly, set for 2 amps right now. Monitoring our boost voltage. We'll wind down the AC. Bring it up. Well, we started with a 2 amp. No, we're still wandering around. Look at there. It started, but we're not working. It was not the controller. Not the controller. She still will not drive a 2 amp load. 1 amp, she's happy. I have had one that failed under load before. Okay, that's not it. Turn that off. Yeah. So what is it? I mean, that controller is, 90% of the circuitry in this thing. All right, we're discharged. We do have these ICs over here. Doesn't seem to be like the voltage regulating part of it, because at no load or at 1 amp, it will regulate 12 volts properly. Anyone have ideas? I don't remember, Andy, if that was the one. I don't remember. I am wondering about something on this side of the board. PFC voltage regulates. What's happening is it looks like basically the load, the 12 volt load generated is constantly changing because of that voltage. So that's what makes it, I think, what makes the PFC go all over the place. Because its load is changing so much. It's going from 0 to whatever. Alrighty, some of these chips over here. Let me get a ground point there. Sorry, let me switch back to the other view. Output transistors. I wouldn't think output transistors though, because she outputs 12 volts with no load. You know what I'm saying? So if you had a short there, it's just going to charge the capacitor up. I'm reverse biasing. It will put out 12 volts with no load on it. Where is pin 1 on this chip? I can't tell. Let's see if we have any low readings. I think that's normal. That's ground. What about this other one? Ground. Yeah. Yeah, I think that's normal. Two and a half. I need to look at some notes from the DR. Where's my notepad? I see 52 up here. .6, 2.5 on pin 1 of IC52. I'm sorry, I've got massive glare on my meter. I apologize. That's, I find odd. That is IC52. It's the top one here. Actually, on my notes it shows showing infinite. It's showing pretty high. I mean, as far as a diode reading goes. 6.2. Yeah, that looks fine. All those look pretty good. Just that one, pin 1, is high. I hate to, let's see if we get about 1 volt across these LEDs on these things. Should be 1.07 or something. 1 volt. 105. And this one should be about the same. Yeah. Those LEDs look to be fine in those opto-isolators. This is going to be a bit of a subtle fault, I guess. None of these chips seem to have a short on them. I've seen these MOSFETs cause some weird, these tiny little MOSFETs here, cause some weird shutdown issues, but not usually like this. It's a different symptom. Like they'll just make it not run at all because they're holding a shutdown. That's how it usually shows up. Now this was an ER, 400 ER. I do have another 400 ER in the box here that I did fix. So I've got something to make comparisons to. Because that's pretty much where we are, is taking a meter and going back and forth between them, probably in resistance mode, and look for big changes. Yeah, anything over about 1 amp, um, it would start shutting down. It didn't do a full shutdown. It was weird. It was definitely oscillating. I just normally would have suspected, like I said, suspected that controller, which we have changed with the original DAP 053. Okay, that's our next stop, though. I'm going to put that chip back in my good parts because I think it's good. But yeah, that's where we're at now. We're going to have to make some comparisons. I mean, I could just swap out these chips. I hate to do that. I'd rather narrow it down. Like I said, I've seen these opto isolators break down sometimes. These tiny little MOSFETs do, that are part of the shutdown circuits. They'll do weird things. I don't know if I've ever seen one do this before. Okay, let me go get something to drink, and I'll be right back, okay? I'll be right back. Thirsty. It's hot. Not terribly hot, but a little hot. Is it fixed yet? Is it fixed? It's fixed, send it. Oh, thank you. Thank you, Worms. I guess I can get my ancient laptop out of the way here, since we no longer need to read any UART codes, do we? Let me dig out. Sorry, I'm eating at the same time. The one good 400 ER that I have here. How do I want to do this? I think I discharged it. Let's open this up. These kind of can be time consuming. Not really suitable for streams. But that's where we are. It's a gnat. Sorry. I need to hang on to this ER. It's the only one I've got. Well, I take that. There may be another one. These aren't the only PS5 supplies I've got. There's 3 of them at my feet. So, go ahead and get that out. Put you over there. Where is my Sharpie? All right, we're going to put a nice check mark on our known good one here. So I don't want to get it mixed up at some point. Oh, hello. You catching some people up there, Worms? Thank you. Yes, this is, I guess this is the third power supply we're working on. Yeah, but this is a bad one. It came out of a PS5 that was, when you could press the button and it would try to turn on, the blue light would go out immediately. It would give you a blue light. And anyway, it turned out being a power supply that was shutting down. And then we swapped it out with a good supply, and that supply brought the PS5 up no problem. This is the supply that was in there that was failing under load. We checked it with an external DC load. Still does the same thing. Anything over about 1 amp of current, and it shuts down. So this is a known good identical board, 400 ER, that I fixed yesterday or this morning, something like that. And we are going to make some comparisons to it. We've already swapped out the main controller IP. IC, the DAP053, has already been changed out. That was a likely suspect, but was not to be the case. Let me get a clip lead. I'm going to connect the two grounds together so that I'm going to be in resistance mode. I'm going to stick that probe down in there. And I'm going to take some resistance measurements. Because I looked with diode mode earlier and nothing really jumped out at me, other than that one, on one of those opto isolators. It was a little bit beyond, it read 2.5 where it should have been like infinite, OL. So we are comparing to a known good supply, which is here with the check mark. All right, I'm going to go down these. I'm focusing on the cold side right now, just as a guess. That's why I've got my grounds common for that. You have to, if you're going to check on the hot side, that's a separate ground. They are isolated from one another. So I'm on the cold common point or ground. So right there I get, well, make sure I'm getting on it. OL. And in 3 k ohms and climbing. And what do we have here? Same. Same. OL. And 1.2 k ohms in climbing. A little different. Had some capacitors to charge up. But it's pretty much the same once the caps got charged. Yeah. I think we're fine there. 97 k ohms and 8.39 k ohms. What do we have up on this one? 95 k ohms, 8.3. That, I don't see a problem there. I don't see a problem there. Let me go around these ICs. There's only 2 ICs on this side of this board. 2 4-pin ICs. 5099. That is, I can't tell if it's pin 1. Let me look. This is IC 131. I'm looking for the, oh, here, pin 1's on this side. All right, so pin 1's on this lower left corner. So we'll start there. 1.6 megohms. Significantly lower. Significantly lower on pin 1. Go back at 1.6 megohms on the working one on pin 1. Oh, now that one changed. Now it's 1.5. I thought that was in the kiloohms earlier. It may have just changed. Yeah. Okay. I think that was a false alarm. I thought that was in the k ohms a moment ago. Maybe it was, but capacitors. Pin 2, 14 k ohms. Pin 2, 14 k ohms. All right, pin 3 of the good one, 50 k ohms. Pin 3 of this one, 4887. Pin 4 is ground. That's just ground, so yeah. Pin 5, 5.099 k ohms. 5.11, close enough. This pin 6, 11.9. 11.862, 6.19 on the next pin, pin 7, 5.995, and what was this one? 6 point, nothing to cry about. 200 k ohms and 200 ohms, not k ohms. And climbing, I think that's on the output. I think pin 8 is like the supply voltage, so it's like 12 volts. So climb, 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 climb. I think that's going to be the same thing that you'll get right here because it's on the, no, maybe it's not on that. Let me try it again. Pin 8. Yeah. Same thing as you get on the 12 volt output terminal. So there's a lot of capacitance there. 1.7 meg on this one. Huh. Yeah. Nothing too suspicious. Let me move on to this other IC down here. IC 101, I think it is. Pin 1, 22 k ohms, 46 k ohms. Is that going to change on me after a capacitor charges up? 21 k ohms, 46 k ohms, pretty consistently. Make a note of that. $21 k ohms on this one. On the good one, 46 k ohms there. What does that mean? I'm not sure, but it's a difference. Pin 2, let's keep going. Looks like ground. It's ground. Pin 3, 19.9 k ohms. 3, 19.5, close enough. Pin 4, 700 k ohms. 1.47 meg. Okay, that's different. 700 k ohms and 1.44 meg. All right, just keep that in mind. Pin 5 is ground, I believe. I think this is a dual op amp. So, like the inverting input or something is grounded. I think that's what it is. Pin 6, 700 k ohms. Pin 6. Oh, hang on, if I can get on the contact. 1.37. 1.37. And 700 k ohms. Different. 6 volt. 1.3 meg ohms here. Yeah. I need to check though to see if these two chips are identical or if they use two different suppliers. 46 k ohms on pin 8. 19 k ohms on pin 8 here. So let me look at these chips because it's an MP6924. I don't think there's but one supplier for those. Yeah, MP6924. So we had some resistance readings a little bit different there. I don't know if that's going to be too conclusive. We'll do diode checks again on that. We're going to take a closer look at this IC 101. I'm going to put red probe on ground. Let's go back through these to make direct diode comparisons. Pin 1 of IC 101, 0.509. Is that getting the glare? 5.1. I'm going to go to pin 2. Pin 2 is ground. I'll skip that one. Pin 3, 657. That looks fine. Pin 4, 5. No big difference. What about, that's ground. So pin 6. That looks fine. I'm going to the wrong chip. Dadgummit. Why do I do that? Because there are two chips in front of me. 1, 2, 3, 4. 1, 2 is ground. 3, 4, 5 is ground. 6, 7. 7 has a lot of capacitance on it. And 8. Go to the right chip. Ground. A lot of capacitance there. 8. I'm not seeing anything that just stands out as being a total red flag. Yeah, these are time consuming. Time consuming. I want to check around some of these tiny little MOSFETs down here. It's Q133. That's doing weird stuff. There we go. That looks the same. That's ground. It's Q133. We're in the megohms. Yeah, we're in the megohms. Ground. Half a meg. What about over here? A lot of capacitance there. A lot of capacitance there. Looks fine. Yeah, I'm pretty sure. We'll look at these. Let me reverse this. We'll look at these output, these rectifying MOSFETs, but I don't think they're going to be shorted because, like I say, it will output 12 volts with little load on it. Maybe there's one to open. I don't know. That's a possibility. Where are they? All right, I'm looking at these MOSFETs used as rectifiers on the output stage. 0.599, lots of capacitance, and ground. And up here, 5.9, lots of capacitance, got to charge that cap up, and ground. And the other one's going to be the same way, ground, lots of capacitance. I think that's basically the gate. That 0.59 is the gate of both of them. Nothing is jumping out at me. What about these tiny MOSFETs up here? That's ground. And 0.57. Ground. 0.5. Infinite. Six, 4, 5. 630. I mean, beautiful. Here's our reference IC right there. Ground, infinite, and 630. Ground, infinite, and 630. Perfect. Another tiny little MOSFET. 938, 621, and a ground. Ground, 938, 621. It looks perfect. Perfect. Everything is perfect. What are y'all talking about? What are we talking about? Red Bull? You're supposed to focus on the task at hand here. All right, let me. All right, same thing. We're going to connect the commons, or the grounds of the hot side now, just so I don't have to move a lead back and forth, back and forth. But I do need to get it attached in there somewhere. Do I have another clip lead over here? Let's see. All right. Nothing and 0.698. Nothing, 0.7. I'll take that. Ground, 0.678. Ground, 683. Nothing, 575. Perfect. And let me go through this. We'll compare them on the DAP 053. Pin 1, 0.7. 0.7. I'm going to go to pin 2, 578. 577. 3, 682. 677. Pin 4, I believe, is ground. So I'll go to pin 5, 655. That's perfect. That's pin 6, 646. Perfect. Pin 8, 1.47, 1.48. Let's go to pin 9, 1.16, 1.12. Pin 10, 1.12, 1.12, 13, 521. Yeah. 521, 478. A little difference. That's the supply rail. I believe pin, no, 10, 11, 12. That's 12. I'm not sure what 12 is. 10, 11, 12. I've got to go let a dog in, because she is barking like she is dying outside. It's just so nice out there. She won't last much longer. Come on. All righty, where were we? Yeah, I was on this side of this chip. 4, 7, 8. A little difference there. Not a huge difference. That's pin 9, 10, 11, right? 8, 9, 10, 11, all right? 12 is no connection. 13, 7, 0. That's fine. 14, 6, 2, 3. That's fine. 15. 16. Nothing. Nothing whatsoever. I'm wondering about the supply voltage for this chip. I could put a meter on that. It's about 16, 17 volts. And it's derived from the transformer when it's running. I wonder if that is dropping away. There are filter caps on it. but they didn't look, I've never seen one fail. 51 k ohms. 51 k ohms. I'm doing resistance checks again now. 1.6. 1.6. On the other side of these optimizers, that's ground. 1.08. That looks fine. 0.5. 0.8. 0.5. 0.8. And 1.18. 1.14. 0.86 and climbing. It's a little different. That is on IC52. I'm thinking. Nothing's jumping out at me. What I may do, there's two different shutdown circuits right here. One of these, this one right here in the middle, is the voltage feedback. That with that little zener right there. That's for regulating the 12 volts. The other two are for shutdowns. Either a shutdown triggered from this side, the hot side, or a shutdown triggered from this side. So I can lift both of those and disable those circuits and see if it's something to do with that. I haven't seen that exact symptom before, but I could lift those temporarily and just see if it will run. No, it wouldn't be that easy, Andy. A lot of connections, you know. And you got to keep in mind there's the transformer coupling power from one side of this board to the other. So it makes it kind of, yeah, not really practical. All right. All right, I'm going to disable those shutdowns. And see if that has any effect on it. This is my known good reference board. I've seen these shutdown circuits, you know, cause shutdowns, complete shutdowns. I've never seen them. Well, I take that back. I have seen them now that I think about it. I have seen a problem with them cause low output voltage. I mean, it would just be low. It'd be like 8 volts all the time. I have seen that. So, like I said, this one here is going to be for the, these are 1004s. It's odd. EL 1004s. This one's going to be for the feedback. I got to leave that one. That's for the voltage feedback. Basically, the LED in here is driven by this circuitry, this reference. Where is that reference? Oh, here it is down here. That reference. That one starts with 0AR. Finally found the data sheet on that little bastard. It was hard to find. It is basically just like a 431 or 432 or whatever, but it's kind of special the way it can regulate down to very little current through it. Okay. I got to disable one side. Or let's see, which side should I disable? I'm gonna lift this side of this one. which this would be the shutdown coming. Oh man, my soldering iron's tangled up with everything. You know, the pin 1's on this side, so that's the control side. That's the LED side. So the control's coming in from here and controlling something on this side. So if we just lift one of these, it won't matter anymore. It won't be controlling anything. We're going to isolate that. We're going to try not to break this pin. Yeah, that's still making contact. There we go. Now we got it lifted. I'm going to isolate that, and I'm going to isolate it on this side as well. This bottom one. Let's just see if it acts any different. I should probably be lifting one of them at a time, but we can hook one back up if we need to. All right, that's lifted now. So we've disabled those two circuits. All right, we're going to test it again then. Let me go back to, not that one, that look. Some of these are just something else to find. I'm trying to decide which way I want to turn the board. I guess I'll do it this way. It's easier to get these. It's easier to get on that big capacitor there. Negative, positive. I'm set for 1 amp over there. Get across our capacitors here. All right, power is turned off. I can keep my arm out of the way. She started up at 1 amp. But will she go beyond 1 amp? No, it will not. At 2 amps, we're back cycling again. It's not the shutdown circuitries. Yep, at 2 amps. 1 amp, we're fine. Caps, well, that's a possibility. That is a possibility. I could remove those big, 2 big filter caps, and we can put a meter on them and check them. Another possibility I was going to check was the supply voltage going to that DAP 053. What is it, and is it stable? The thing is, once it starts going into this, oscillation it goes into, all those voltages are going to start going everywhere. So I don't know if it's a good test. You know what I'm saying? Like when everything's wandering around like that, is anything stable? But let me check it here. I'll tell you what, I'm going to turn that off, get this out of the way. This thing is still active and hot right now, so I'm going to be very careful. I'm going to flip this over, and we're going to check the supply voltage for this DAP 053. Still connected to the load. And I'm trying to remember, is that pin, pin 13. on this chip is its supply. Let's see what it's running. 16, 15, 14, 13. I was looking for a good place to get on it that's not right on the chip because I'll slip and short something out. C79 here, I think is. No, that must not be the same thing. Pin 13. Yeah, C79 is the same point, isn't it? Oh, I'm in AC. That makes sense. I had my meter in. I'm sorry, you can't even see it. But I had my multimeter in AC mode for some strange reason. I don't know why I put it there. All right. I'm going to get on a capacitor here, which is on that same point. 12.16. And if I turn this up to 2 amps load, and she is going all over the place, isn't she? What about with no load whatsoever? 12 volts. I'm trying to remember. Here's the thing though, this voltage is being derived by the 12 volt switching transformer. So if that's going up and down, I can tell you this voltage changes with the load on the output. And I have some notes somewhere as to what it changes is, but normal it's about plus 18. Let me look at another. I thought it was this one. It's just that a problem on there, somewhere else can cause this voltage to go all over the place. And it will go, the voltage here is down with the load. Like if there's no load on the output, because what happens is it's another winding on the transformer. Let me show you. You see this here? Like this is your transformer generating the 12 volt output over here. So it drives this harder and harder as it needs more current on the other side. All right, and the feedback of how hard this should drive is based upon the level of the 12 volts on the output side. So, but then you have this winding on the hot side generating the supply voltage for that chip over here on pin 13. And that's allowed to just wander all over the place. They don't really regulate it really tight and you know what I'm saying, they let it wander around because the chip probably doesn't really care if it's 15 or 18 or 17 as long as it's above a certain amount. So there are filter caps here on this. Like here's a filter cap, there's a filter cap. I've never seen them fail. Any cap can fail. C25? Where is C25? Where is C20? I don't see C25. I'm sure it's in here. And that sounds like a capacitor on the hot side because it's in those double digits. C25. Oh, you're talking about that 330 right there? Possibility. But you see what I'm saying, though? It's not unusual to see this voltage wander around. I can tell you, it's going to be like 18 volts with like a 5 amp load on it. And it may be 12 volts, 13 volts with no load. Because it varies according to how hard this transformer is being driven. And of course, yeah, weird things are happening. In theory, I mean, like, as the load goes up out here, the harder this gets driven, the more voltage you have here. But yeah, we can check. I've never seen these fail, though. I can tell you C25 and C27. No, I don't think it's anything thermal. I really don't. But those are easy enough to take out and check. I know where they are. But like I said, I've never seen them fail. Never seen them fail. All right, this thing is still on, so I'm not sticking my fingers in there right now. We're going to turn this off. We're going to turn this off. We're going to discharge some caps. Like I said, these big caps look to be pretty healthy, the way they hold a charge. But we may have to check those as well. But that C25 and C27, or is it 27? Yeah, right in here. Right in there. All right, let's check C25. Where's the other leg of C25? It is right here. They like to bend the legs over on these capacitors. C25. Just feeling of the weight of it. It's supposed to be a 330 at 35. It's a nice Nichicon capacitor. Let's see. What does she read? It's 120 hertz test frequency. 324 microfarad. Effective series resistance, 0.08 ohms. That's a pretty good cap. Pretty good cap. All right, C27. Make sure that's the right, yeah, that's the right cap. Yeah, trying to make sure I get these things oriented back properly. These leads are bent over. No. Okay. You willing to come out now? Almost. All right. C27, 47 microfarad, 50 volts. If I don't, 47, is that right? 47 at 50. 42.83. 0.79, 0.8 series resistance, effective series resistance. I don't think that's our problem. I just don't think that's our problem. It is a little low, but yeah. Yeah, I was feeling the weight of it. Zener diode? Well, could be. What's odd though is, like I said, this thing will regulate perfectly with no load or with a 1 amp load. Yeah, I just don't think that's our problem. Not the issue. See, I've never seen those fail. These are all on the output. What is C140? I'm not sure what that does. I need to put these back in here before I forget about it. And hopefully I got them back in there the right way around. I had a roll of solder somewhere. And it left. Oh, okay, I see it. I see it. It's behind my canned air over here. Let me just tack these back on. Yeah. Okay, those are back on. I could check these big monster caps here, but these are 180s at 450. Kind of hard to check in circuit. I mean, I could, but then I hate to break. What if I just, let me try. I'll lift one leg of this thing. I'll lift one terminal of these so I can lift it out of the circuit. And we'll give it a check. This is kind of easy to get to. Get it isolated. I think I can do this. I'll pull it out of the board there maybe. Yeah. So that one is one leg of it's isolated. Now can I get on it with these leads? I do want to make sure it's discharged. I don't want to blow up my capacitor checker here. Ooh, little charge on there, wasn't it? Yep. A little bit. That's why I do. I don't want to damage this meter. Gave us a little bit of a spark. So I'm going to say capacitor is It's pretty good. It's holding a charge. These big ones, you know, can hold one for a while, and they will charge themselves back up, which is, it kind of lingers. The charge lingers, and all the different layers of it in there. 155 microfarad. It's a little low. That is at 120 hertz test frequency, which that's not the frequency hitting this thing. It's going to be, let's raise this, let me raise the test frequency up. Set up. Nope, nope, nope. Oh, hit there. How about 10 kilohertz? And it went down to 127. What is it at 1 kilohertz? 150. A little low, a little low. Yeah, it's a little low, but I don't think that's our problem. I mean, you know, might could cause a problem at the high end of the load or something, you know, where they would have to be working their hardest. I mean, but we're trying to just do 2 amps, and we're falling over on our face. I'll check the other one, though. I'll check it, and I might even replace the damn things. What the hell? Again, it's hard to get. I was trying to avoid, you know, let's just remove them and check them. At this point, but like I said, you know, these things were designed, there's going to be a certain amount of tolerance. Those capacitors aren't going to be exactly, you know, not going to read exactly like you'd like for them to do. And one of those had a little bit of a charge on it earlier. That one is clear. I'll just remove the thing so we can get to the leads really well. I don't have any, I only have one 150 lead. I do have 220s though. 220s should be just fine. I have plenty of those. I think they're the same, roughly the same physical size. Yeah, that's good heft to it, good weight. It's not dried up. All right, here's the other one we had not checked. I just knocked the tilt bell off my meter. Which one was it? I think it's that one we haven't checked. Yeah, that one's got the lead pulled up on it. This one has some weight to it too, so I don't think it's not dried up. 151. I don't think that's a problem at all. 151. This is checking at 1 kilohertz. They read pretty much the same. I think those are good caps. The meter, I bought it used off of eBay years ago. Every meter I have is bought off of eBay used years ago. It wasn't broken, it was just a used one. But yeah, it's a nice meter. It's a few years old now. So I can replace those capacitors with some 220s. It's not going to make any difference. We have a more subtle problem. Let me look under the microscope a moment. Just to see if there's anything discolored or with a crack in it. There's your resistors for your PFC feedback. 7.5 meg, 7.5 meg, wind its way around. There'll be I think it's a 95K to ground. Anyway, that seems to be working. So that does regulate. With little load, that regulates just fine. There's our DAP053. All the pins look to be soldered well on it. I haven't cleaned that up. That's where I removed those capacitors, those small capacitors, C25, C27. Yeah, knocked the trace up a little there. Yep. It'll be a more subtle issue, I think. Failing under load. Which just made me suspect this stuff over here on the cold side. MOSFETs. That's your reference IC. Yeah, I've still got these lifted. Feedback is still in place. Something I could do, which I've done before, is I could actually hook an external DC supply, to power this chip, so it's not reliant upon the onboard one. I don't think it's going to make any difference really, but it's something you can do if you suspect the onboard supply. I mean, because this could be, if you think about it, this could be a bad transformer as well. Haven't seen one. I mean, they usually, I've seen some broke loose from the board. Usually it's like it's the PFC coil. Somebody drops one and pops it off the board. But she's not going to run at all then. Yeah, this ZEW here is the transistor that it's regulating that supply voltage, that 17, 18 volts to the DAP053. But it will wander around like that. That's not really an issue, I don't believe. They don't regulate according to that voltage. Current sample. So we've got some of that yellow nicotine film there. This is towards your AC input. There's your bridge rectifier. She's starting, she's running, which is normally a big advantage, you know. It's the ones that won't start at all and you can't figure out why. That's the tough ones. I mean, usually if it'll start, you're halfway there. I mean, so over here, though, is where it would be detecting the load, the output load, and then feeding back correction voltages. And with no load, that's absolutely perfect. 12.1 it was, I think. Oh, the transformer? Yeah. Yeah, I've done that before as far as feeding it. Well, it just kind of eliminates, you know, the varying of the supply voltage. That's a possibility. I've been streaming almost 4 hours. What time is it? Like one. I don't think we got a bad IC because, you know, we swapped it out and the symptoms are the exact same. So not very likely that I got a bad IC with the exact same problem as the old one. Not very likely. I need to eliminate something. I can replace these ICs here. That DAS01B, I have that one, and then this IC right down here. I do have those. That maybe that should be my next step. Swap those out one at a time. I mean, all their, you know, the comparative readings looked fine. But then again, it's not like they failed totally, because she will work fine at 12 volts. I mean, at 1 amp of current. So it's not like they're shorted or anything. Something is just on the edge of working, which I was hoping to find was like a broken down capacitor or something. That's why I was using the resistance mode on the different legs, hoping I would find something, you know, a really low reading. Not a short necessarily, but just a low reading that would stand out. Okay, we need to do something. We've stared at it long enough. What I'm going to do, I think, I'll tell you what I'll do. I'll go ahead and put 2 brand new 220s in here at 450 volts. If they will physically fit. So they're a little bit longer. So I got to make sure I've got the room for that before I commit to that. I think we can sneak that in there. This one definitely, it's the one wedged up against this transformer. And we're not going to put it in backwards, are we? No. We're not going to put it in backwards. But we'll go ahead and put some shiny new. Let's just see. We'll see what one of these measures. Brand new 220. 188. Well, these got shorted. 188. Yep. The test frequency will have a lot to do with it, and they're going to change a little bit when voltage hits them. But that's a brand new Rubicon, probably maybe a year old, 105C, good quality capacitor. 188. And the other one, $187. So there you go. That's what they are. Let's pop those in there. And I'm not going to bother gluing them down yet, because why? I'm just double and triple checking polarity. Look at that, fit like a glove. And I'll fire it up. I don't think it's going to make any difference, but we'll check it, and then I'm going to start replacing these 8-pin ICs on the output side. To get that down to the board pretty good. Yep. I'll glue them down later on. All right. $220s at 450. And the polarity is right. Okay. Everybody leave yet? No? All right. Positive, negative. Get across our capacitors. Oh. No. There it is over there. I lost my negative lead. All right. Let me get where you can see. So, I'll wind that down. We're still set for, I'm going to just give it one, hang on, set 1 amp. It's on, yeah, 1 amp. We're started. Yeah, that looks stable. When we go to 2 amps, we fall on our face. We fall straight over. What if I keep going? 3, 4. It is saying, please stop. 1 amp. All right, so, yeah. Yeah. What's people saying here? I'm here till it's fixed. Oh, Lord. I'm not here till it's fixed. I'm not here till it's fixed. I mean, not in stream. I'll fix the damn thing, but... All right, let's discharge this, and we're going to swap those ICs. Not something I like to do, just swap out parts. But we'll do it. I've got them, and we'll do them one at a time. And when I figure this out, then hopefully I'll remember this one, and the next time I have this issue, it'll take 10 minutes to fix and not 2 hours. Come on, Pastor's got a hold of my clip there. All right, so let's just pick one. IC 131 is that DAS 01B. Okay. Which I know I have some in the drawer. Because I've had to use them here recently. I'm getting a new chip out. Pin 1 in the bottom left. Oh, come on, let go. Pin 1 in the bottom left. My leg has been on this chip. So this is a new part. It's not a pull. Yes, this soldering iron is much too big for this, but it's the one I grabbed, so we'll make it work. All right, that is installed. And I did get it turned the right way. All right. I cool it off just a little. It's a little warm. Just a little warm. All right, I'm just going to hook the load to it. And see what happens. Well, we start, we run, and if we go to 2 amps, we fall over. Yep. No change. So I'm going to put that in the drawer. That's going to be a good chip. No change. And I don't think the other one's going to make a change either. I'm going to do it, but I just don't. This is one of those weird ones. And when we find it, it'll be like, oh, we should have gone to that first. Discharged. And the other one is an MP 6924. Or am I just making that number up? Yeah, I got it right. MP 6924. Which I have a few of those as well. Yeah, we may not beat this supply today. But if we don't, maybe we'll just continue tomorrow. I have a new chip. I don't think I've ever seen this exact problem. I have seen some die under load, I think, but I may have to go back. I may have a video on this exact problem. I don't remember it if I do, though. I don't remember. All right, pin 1's in the upper right. Get off the board. Get off the board. Come on, stick to the board so I can. A little out of focus, I'm sorry. I need to lower it a little bit more. So these chips don't usually fail unless there's lightning. And then anything can fail. I don't really have any signs of lightning on this one. I mean, nothing. No arc marks, nothing. Yeah, pin 1's in the upper right. Okay. We'll test it. We shall test it. Set that chip to the side. Positive, negative. I'm not even hooking that meter up right now. We can see when it's going crazy looking at the load. It's pretty obvious. All right, I'm set on 1 amp. I'm going to dial it down, just bring it up slow for some reason. I don't know why. It's not really having trouble starting. And we start up and we run at 1 amp. And when we go to 2 amps, we fall over. No change. No change. Back to 1 amp. Turn that off. Okay, well, I'm trying to decide if I want to supply 18 volts to that IC or not. I've got some leads here. Here's the other one. I have not discharged this yet. I'm contemplating my life choices right now. What choices led me to this point? This could be a problem with the transformer. It could be. It could be. It could be a problem with that transistor that somewhat regulates the voltage, to this chip. It goes through a little passing transistor. I've seen those fail in cases of lightning, but that's about it. But this would eliminate that if I give this thing, I don't know, 16, even like 17 volts. This is one of those things, you get into a sketchy area, you got to be careful. I'll be connecting a DC supply, an external DC supply to this thing, although I am going through, when I go through this transformer, this is isolation. It's not just variable AC, it is isolation. So it gives me a level of safety there. You can just end up, if any of you worked on TVs back in the day, hot chassis TVs, you could end up burning, like hooking a scope to something like this it gets sketchy. You really need an isolated scope. But technically I am isolated by this transformer, so there should not be any ground problems. Shouldn't be. But do I want to hook a $500 bit supply to this thing? I'm sure it'll be fine. All right, I have not discharged this yet. And we have even more capacitance than we had in the beginning on this thing now, since we changed those capacitors out. All right, let's discharge this though. Taking a little while to discharge, isn't it? Okay. I'm going to unplug it from the pin 13 is the supply voltage. So basically right across that large capacitor right there. 16, 15, 14, 13, right there. Yeah, it gets dicey. I'm hooking my supply up to a hot side of a chassis. So I'm looking to see, I have several supplies here. They're not plugged in though. I have several that I wouldn't care if I blew up, if you know what I mean. It should not be a problem, because I am going through an isolation transformer. Otherwise, it would be a problem. It would be a big problem. It would be a ginormous problem if you didn't have isolation. All right. I'm going to connect. Oh, that's ugly. And it doesn't have to look pretty for right now. Alrighty. Oh, switch back my view. Oop, wrong one. I just want to blow up my power supply. Let's see. I'm going to set this supply, but you can't see it right now. I'm going to set it on, let's just say 17 volts, maybe 16. I mean, either one should run it, really. Oh, come on. I'm sure it'll be fine. I'm sure it'll be fine. All right, I'm going to say 16 volts. And I'm going to set the current to probably like 100 milliamps, which should be way more than this chip uses. Okay. So let me see if I can set it where you can see. I'm on the B channel, the secondary channel there, this one here. And I'll just go ahead, I can give it that voltage right now. Yeah, we're getting a lot of leads involved here. A whole lot of leads involved. I'm gonna hook the load back up. That's really the only way we can test it, is if we load it, because we know it works with it no load. All right, here's the leads of my second channel. And I'll just give it, I'm going to turn that on, make sure there's no problem. Because there's no AC coming in right now. I just want to see how much current we get. That's weird. I don't know why I said 11. Something glitched there. 16 volts, no current. So it doesn't draw any current. So let me turn that off. Kind of hard to show everything, isn't it? Let's see, how do I want to do this? I think what I want to do is plug it in. I'm going to leave the power supply off. It may complain. Like, because there'll be DC feeding into it from the supply here, and it's probably not going to like that. It should have some isolation, you would think. That didn't come up. What did I do? What did I do? what did I do? Load is on. I didn't see it start. I can go ahead and give it 16 volts. See what happens. Nope, we're not starting. We are not starting. Does it not like my supply being connected to it? Let's get rid of that. Get rid of that. Does she start now? Yeah, he didn't like that. He did not like. Okay. Turn that off. If I connect just the ground lead, does she start? Yes, she does. Sorry, my arm is in the way again. So she'll start with the ground lead connected. I'm wondering if I'm, if I'm loading a voltage down when I connect it. She's acting weird. Acting weird. Yeah, I'm trying to be careful. I did not solder the optocouplers back. Those are for the shutdowns, though. Those are for the shutdowns. I left the one in place for feedback for voltage correction. Yeah, this is getting weird. Uncharted territories here. You know what I need is a simple diode to put in line there. Let me grab a diode. Somewhere I have a drawer full of 1N4004s or some Schottkys or something. Something to give us some isolation. Because what I'd like to do is bring it up, let it start that oscillating or whatever, and then I'll apply 12 volts, or 17 volts from my power supply. And with this diode, it can't feed back into it. Now there's like a 4148 signal diode. I'd like something a little bit, here we go. Something a little bit tougher. In theory, there's no real current flowing here, in theory. I'm talking milliamps. All right, what is this? I found this is a 4004. A very garden variety diode. But this way it cannot feed back into my supply. And I cannot load the supply. I can't load the internal supply that way. All right. Lovely soldering job. We've got it. All right, now I can connect this to that. We're isolated DC wise. That's still set for 16 volts, 100 milliamps. So I turn it on, it should start here. And it does. And we're regulating. Of course, we're only at 1 amp load right now. So what happens if I turn this to 2 amps, we get unstable, and then I turn on my bin supply here. Hey, we stabilized. We stabilized. Look at that. 3 amp load. Drawing 8 milliamps off my bench supply. Sorry if there's a lead in the way there. Can you see that though? Now that we've stabilized that, I'm wondering, all right, we could have a problem. We obviously have a problem with the supply to that chip. You know, we were chasing down capacitors earlier. It wasn't the capacitor because there's a few other things involved, such as here's that winding of that transformer. There's actually a little capacitor, like a resonant capacitor, across it right there too. There's a diode. There's a filter cap. So this transistor here could be bad. Zeners. We check this capacitor and this capacitor. Don't think it's this Zener because right now that's straight across the lead going into the IC. That's going into pin 13 right there. So if there was a problem, if that was shorted or something, we'd have a problem right now. And I'm connected to that same point. I'm connected across that 1 microfarad capacitor right there. That's where I'm connected. And I'm bringing in 16 volts. ZD31 is a possibility. I'm thinking this transistor right here. What do you? I'm thinking that transistor. I don't know. It could be the Zener. I have all these parts. I have this diode. I have this Zener. I have this transistor. I've even got this diode, I believe. Interesting. Now, I hope we don't have a problem with our transformer over here. Possibility. The most likely thing is, though, we got to swap this out. We got to swap this out. Yeah, you're talking about the other Zener. Yeah, this Zener's a possibility. This one, I said, we're connected across it right now. And that Zener, I had to look it up. Excuse me, I had to sneeze. It's not breaking down right now, I'm saying. I'm giving it 16 volts, minus 6/10, 7/10 of a volt drop across that diode. Don't think that's the problem. Let's shut it down, swap out this transistor, and see what happens. How's that sound? But that's good to see. I'm not going to bother. She's stable at 3 amps right now, no problems. And if I turn that supply off, I'm sure she'd come unglued. I'm going to turn it off, turn off the AC input, turn off the DC. Not going to forget to discharge our capacitors. Not going to forget it. Let me get that out of the way. Okay. That's some progress. That's good to see. Discharge these capacitors. Yeah, that ZEW is just a it's an NPN transistor. Nothing fancy. Nothing special about it. I've often wondered though why they don't like that. Even that with that Zener and that transistor, they don't regulate it hard. Like they're not trying to make it be 15 volts or 16 volts. It's like they're limiting it. You know what I'm saying? Like they're trying to limit the high end of it. They really don't care if it wanders around a little. But in our case, it's wandering around a little bit too much. All right, we got to find that transistor Q31, and let me find the ZEWs, which I have a drawer full of them. Those used to die. The same transistor was used in the old PS4 power supplies, which is why I have them. There they are. If you want to know the part number for it, well, good luck getting it to focus. But anyway, It's just it's a very garden variety, common, NPN. It's 40 volt, 2 amp. Now let's find it on the board here. Someone's in my driveway. Just a moment. Oh, just the neighbor. It's not the FBI. Okay. ZEW. See it right there? Or ZEW for those of you across the pond. You know what I mean. Let's get that out of there. I'm trying to remember. I think I put a meter on it, a diode check meter at one point. I can't remember if the reading was a little off. But see, this is one of those weird ones that's hard to find because nothing is dead shorted. It's just, being a semiconductor. It's somewhat shorted. It's working a little. But the next time this happens, assuming this fixes it, because we still don't know that it's not the transformer. Or, like I said, that should be fed from, there's going to be a diode. I think it's at, no, it's a ZD31. Where's the rectifier diode? Maybe that D21 right there. It's the one that rectifies it. Yeah, that's going to be D21. You see, there's the winding off of the transformer, 2 ferrite beads in parallel, diode, and then it splits. There's some, the capacitors are down here somewhere. You can see see how it jumpers there. Anyway, where was my transistor? Right there. Need to get you off of the board. There we go. What did I do? I laid my new one down. Ah, damn it. I laid it on the bench and then flipped it into eternity. So, I get to dig out another ZEW. Since I have lost that one already. Just that quick. Okay, how about I put this one straight on the board? There. That other one will turn up. It's probably stuck to the top of this power supply right now. Alrighty. I'll find it at some point. Stuck to my arm or something. All right. Is that lead broken loose? No, it hasn't broken loose. Okay. We've replaced that transistor. Is it going to work? You still thinking ZD31? I don't know. It's a possibility. Let me switch back. Let's find out. I don't know which one it is. But I know the area it's in now. I know the area it's in. I have got so much junk laying on top of stuff here. I'll put the load on it. I may even hook up my leads for the boost voltage. Why not? Wow, this is getting messy. Stuff piled on top of stuff. All right. We'll dial that load back to 1 amp. Okay. Nothing shorted. I'm just going to get that diode and stuff out from under there. Make sure I got my load collected properly. Removing my arm out of the way. That's all out of focus. All right, I'm going to bring up this voltage. She should start. We're still at 1 amp of load, so we should start no problem. That looks good. We've got a glare on it though, 393. You can see that boost voltage is fine. Now what happens when we go to 2 amps? Oops. And, oh, we're falling apart again. We're falling apart again. So, not ZEW. Not. It's not that transistor. Oh, it's 5 hours. God help me. Oh, I'm ready to stop. We're too close to this thing. What else could it be? There's the Zener. There is this capacitor here that's looks to be like a resonant capacitor across these windings. Diode here. Let me get that to catch back up live. These caps are a little low, but they're not bad. We replaced this. We've got this diode here. We've got some resistors involved. Oh, this is from a ADP 400 FR, by the way, but they use the same circuit. That's why I'm like, this is from an FR. But they use, it's the same circuit in the DR and the ER and the FR. The GR. Zener. Yeah, it does look like a classical, but it's not. Like if you look at this thing, look at this resistor around this Zener here. That's not normal. I'm saying is it doesn't regulate it hard to 18 volts. It just kind of seems to act like a limiter. It doesn't give you a solid voltage out here. It will vary, I can tell you, from plus 13 up to 18 easily, according to the load happening out here, because this drives harder and you get more voltage developed. And I don't know why, but they don't seem to try to hard regulate it. They just don't. Obviously they could. But I gave it 16 volts out here and it was rock solid. Do we have a resistor that's changed value or a crack in a resistor? We can check this diode. We can check this diode. So it's D21. Okay. Oh, this is just taking a beating. I'm never live streaming again. I sure thought it was going to be that transistor. Just I've seen them fail. Not like this though. I can't say I've ever seen them. You know, I've seen them fail with lightning. But I mean, anything fails with lightning. All right, back under the microscope. It doesn't work. No. I don't have that set up. All right. Here's the large diode, D21. You can't see my meter because I'm in microscope mode here. 0.569. I don't think there's a problem with that. There's a diode here. 0.590. The diode here. 0.590. C31. Yeah, that's that capacitor across those windings. You can see it there. Which it looks fine. It's a 0.01. It's like a, I think they're trying to make it resonant in some way across those windings. But it's, you know, doesn't look cracked or anything. Where's the Zener? ZD31, which is going to read fine in the forward direction, which really means nothing. Reads 0.73. Reverse direction kind of goes over. I'm looking at the solder. I knocked off that end of that resistor right there. All right, let me get zoomed in a little bit more. We'll get there. Did I cause a problem there? Did I cause a problem there? That is R33, 220 K ohms. And I'm trying to remember if that is part of that circuit or not. R33. Yeah. That's that one right there. Did I damage it? Did I damage that resistor? Oh, I wonder if there's voltage there. I'm reading 900 K ohms there. Of course, there may be some DC voltage. And I'm reading negative resistance, so there's definitely some voltage there. So that's not a good test. I need to discharge a capacitor or something here. Because if you get negative resistance on your meter, there is a capacitor somewhere. I'm about to break these leads, meter leads. Oh. I was just wondering if I had knocked off too much solder off the back. I just don't think so. That one's been knocked around a little. Something in this area. Can't really get a good check in circuit. Yeah, it reached 30. Yeah, this way it reached 35.8 K. It's a 36 K. That's 10 ohms on the nose. I will resolder the end of that resistor right there. Diode reads 0.6, 0.7 on that one. I didn't put enough solder back there. Is that connected? Yeah, it is. It needs some more solder there, but it's still connected. So this is that coil. Wait a minute. Wait a minute. Is that the right place? Between there and there. Wait a minute. Maybe I'm on the wrong. Am I on the wrong pad? I'm trying to get on the legs of that coil. The winding that produces that voltage. C31 is supposed to be across that. I'm reading 11 megohms across there, if that's it. 11 megohms. Yeah, C31. Right there. I'm measuring across there and getting 11 megohms, like this winding is open. Like that winding is open on our transformer. Yep, that's pin 1, 2, 3, 4, 5. And across those two, I should have like a few ohms of resistance, if any. Our freaking winding's been open the whole time. Let me get my orientation right. Look at that. Look at that. Yep. See, the larger ones are for the, the power, actual power stuff, for making the 12 volts. That, and there's another one right there, a small one. That is broken. Has this thing, has it been popped loose from, oh look, oh, okay. Look at this coil right here. This thing has taken a drop. It has taken a drop and is wiggling. I think they've busted the plastic. Yep. Yep. All that for a broken coil, a broken winding. I have not seen that. I've seen the other windings break. I've never seen that one break. While leaving the other ones intact. Let's get this stuff out of there. Did I discharge this thing? Did I discharge it? I don't remember now. Why do I have a headache now? Yeah, I discharged it. I discharged it. What time is it? 2:29. All right. I need to get this thing out in my hands to be able to fix that. It means I got to unsolder these large solder connections over here. Yep, which are going to be I don't know if I've taken these up. Well, I take it back. I don't think I've ever had to take one of these out. I've had to take the PFC coil out. Of course, it only has 3 connections. It's got like, the in, the out, you could say, and then there's like a ground, for the shielding around it. It's pretty simple. If you ever look at one of those PFC coils, there's a lot of extra legs that don't do anything. They're just mounting. So yeah, what was happening on this thing is that DAP53, it internally makes the startup voltage because it has access to the drain voltage of the PFC, which is here I would have had about 160, 170 volts, rectified 120 with a little bit of filtering. So it internally makes a startup voltage, which ends up over at 13. It does that internally, and that's what it was doing. It was making it starting, and then the other voltage is supposed to, be generated and take over, and then it would just fall over because that didn't happen. And then it would start again, and it just, that's how that was. So internally, it makes its own startup voltage, but it won't sustain it any length of time. It's just the startup voltage. Let's get this bad boy out. I'm getting tired. But at least now we know what the problem is. We sure went around the world to find it, though, didn't we? And this is going to put up a fight. I may have to have some hot air. These are these large windings on the output of this thing, and they are substantial. Maybe a little lubrication would help here. I get these out though, the other ones won't be a problem. These are some large, and this is I'm on this, the center ones here are basically hooked to the ground plane. They are hooked to the ground plane. And they do not want to give up. One moment. Let's do this. So I don't think I've ever had to remove one of these before. Yep, it's got a lot of surface area. All right, get over there. There we go. And how about you? Almost there. If I can get my solder wick out of there. All right, look at it wiggle. Yeah, I think the plastic's cracked on this thing. I may have to glue it. I do have a donor one I could pull from, I guess. I've already stole the PFC coil off of it because the same type thing had a PFC coil that was physically busted. And I didn't think it was going to, stick around too well. So I replaced it. Close. Huh. Yeah, that pin's not, one of the pins is staying on the board. It may not be anchored to anything though. Trying to take my time here and not just yank it out of there. There we are. Yeah, one of the pins stayed in there. Where'd it go? I don't think it's a pin that's used though. I thought it did. Okay. We have the offending item. Now we can get a better look at it anyway. It is the winding of the transformer. Physically broken. The one responsible for generating the supply voltage for that chip in runtime when it runs. That one's broke. Both of them broke? Let me get this set on the bench so I can maybe not shake quite so much. Well, there's one, and there is the other. The big ones are fine. Where's the rest of that wire? See, I lost a pin, but I don't think it's, is that the one that's used? I can't remember. This is like the ground pin. It's also like ties. You see this wire going off? That's going to the shielding around. There's layers of like copper foil around this, like a shielding type thing. So let's look at this. Yeah, pin 3. Oh, that's cracked, isn't it? That plastic is. But pin 3 is not used. I'm sorry. I'm trying to. This pin is not used. It's just more of a physical mounting. It's not connected to anything. However, pin 1 and 2 we do need. Is that? Yeah, that's cracked also. Yep. So wherever that, I dropped that pin, I guess. I'm guessing the rest of this winding. Yeah, there it is. I found it on the bench. There's the rest of our pin, which would have been, yeah, right there, like that. Oh, I got to glue that. So anyway, you can see how it went. It was in there. I'm going to have to slide it up in there and glue it, reconnect that wire. And this one over here, the same way, that has broken loose. This is the ground one. I mean, this whole thing is like, look at this. Oh, yeah, that's all broken. So that all needs a touch of glue so that it'll stop wiggling like that. Is it broken on? It's broken on both sides. So yeah, this definitely took a drop. Okay. It took a drop. Is that clear? Can you guys see it? Maybe I should zoom back out. So yeah, it took a drop. The whole pin structure, the whole mounting thing is busted. I gotta get a pin back in there, glue that down, solder the wire back there. That pin doesn't do anything, and these are the drive pins for the input. That's what it drives. They didn't break. They're a lot healthier, but they are going to break if I don't secure that in some way. And these are the output pins on the 12-volt side that gets rectified. They are beefy. That's why I was struggling to get those unsoldered. And these two here in the middle are tied to the ground plane. So yeah. Anyway, so now we know the problem, and I need to glue it and set it up. And now I need to rest. I skipped lunch and be doomed after serving 35 amps. Yeah, this thing took a drop, I'm sure. But at least we found it. We went around the world to find it. This one doesn't have a startup resistor. I know some of them used to do that. They would have a high ohm resistor to go in, and this TAA 2016 does it a little different. They do it internally. Same concept. It's a startup voltage, but there's not a simple resistor on this one. Anyway, I'm tired. I'm gonna have to glue this and fix that coil, but that'll fix it. I just hate that it was so long. Maybe I should have checked that coil to begin with. I've never had that issue. I've had the PFC coil break. I've never had that thing break. But it definitely took a drop. But that will fix it. And I forgot how we started all this. We were repairing a PS5, weren't we? We were fixing a PS5, which is fine now with a loaner power supply in there. But yeah, I will glue this one overnight and put it all back together. Perhaps we can continue this tomorrow. What do you think? Sylvia, if you want to look at the data sheet for the TEA 2016, let me find it. DAP 053. That's the wrong one. Let me pick. Where is it? Where is it? It's not that one. Why can't I find the one that I want? Oh, there it is right there. If you look at this thing, it'll show you how it generates the startup voltage. It does it internally because remember, this chip is the PFC controller, so it has a direct connection to like the boost, this Sense Boost. So it has available to it, 180 volts or whatever, or if you're in Europe, you've got 240 voltage, that's going to be 300 and something volts, or 340, 350. So it internally uses that. It'll tell you, sense input for boost voltage, externally connected resistor divider, where is it, range voltage? Well, they go into, startup and supply. See, it has access to that drain PFC voltage right there. And that's where it gets its startup. Internally it does it, because it has access to the, they just do it a little more elegantly. This is more elegant than using a resistor and a capacitor. Probably a little more efficient. I'm saying they do it internally. It's not, not simple, but you can actually measure it on there. I mean, when it's in standby, you can see voltage there as it internally routes it to pin 13. But it's just for startup, and then it expects for the external one to take over. Internally, a high voltage current source is located between drain PFC and supply IC pin, figure 3. So it's a current source it uses to charge up, and it'll kick it over, and then if that external supply doesn't then take over, it's going to fall over, which is what we saw over and over and over again. When startup is complete and the LLC controller is operating, the LLC transformer auxiliary winding supplies the supply IC pin. This is an operational state. And that's how she works. Anyway, where am I? Oh, I guess I need to go to 5, don't I? I need to go to 5 hours. Yeah, I'm saying it's a current source internal is what it is. It's a current source internal that will shut down. So I think they're trying to get efficiency with it, so it's not constantly trying to draw power off of it. I think they go for like really low standby currents and stuff. They're really trying to get it to be efficient. All right, I'm 2 minutes away from 5 hours, which is probably the longest I have ever streamed in my life. So I guess we're gonna go till 5. Oh, I've got a mess to clean up on my bench. So many parts. I need to not lose that leg, although I could take one from something else. But yeah, well, that's how my repairs go sometimes. That's how they go right there. Which is why sometimes it'll take me days to fix some things, but I can do that because I'm just a hobbyist. I don't really have to make money at it. So I will spend 2 or 3 days trying to figure out what's wrong with the power supply for the mere satisfaction of fixing the thing. That and the knowledge you gain when you do that, it makes you look at the data sheet and figure out, how this works and how that works, and it just makes you better at it at some point. You have to. It's impossible not to learn something if you chase it for hours. We're 40 seconds away. 40 seconds away. Well, thank you all for coming. I'm glad a lot of you stuck around to the end here. I'll try to glue this transformer up. Yeah, I'm still streaming JFix. I'm not sure why. We found the problem. I busted transformer. I'm going to I'll glue it tonight and have it ready to reinstall tomorrow. And then maybe we'll continue then. Right now, I'm tired and hungry. So, we've made it 5 hours together. And I'm surprised my microphone has not... Oh, my microphone is down to getting low. It hasn't died yet, though. So, there we go. Yay, 5 hours. We did it. We did it. We did it. Okay. Well, bye for now. I'll try to catch up with you tomorrow. Thanks for coming. 5, 4, 3, 2, no face reveal. Maybe later. 1.